Hi guys, welcome to Learning Electronics Repair. We've seen this before, so this is out of an active speaker, HK Nano. And this just goes into protect mode and stays in protect mode. I also have the other PCB attached to this, so this is effectively the mixer section. You can see the model number there now. This is where the protect light is on here, okay? And this is basically just lighting up and staying on all the time. So that's the problem with it. Now, in a previous video, I had a look at this and I came to the decision that there was nothing obviously wrong, like shorted transistors or anything like that. All the voltages seem to be up. These two chips are actually the amplifiers, the output stages. This is a Class D amplifier. Now these have a built-in protection feature, in fact a number of different functions which are to do with protection. And they have an output pin which effectively gives you a sequence of pulses that tells your circuitry that may be monitoring this that you have a fault condition. But on this particular unit, that pin is not actually connected. The internal protection is still there, it works. You can't disable the internal over current, over voltage and various under voltage. I think there's also DC offset on the output, a number of different conditions. So you can't disable that. But what's happening with this unit is that that signal is not actually being monitored. There is some external circuitry on here that actually generates the protect signal to the LED, and I don't know where it is, or I didn't know where it was. So having nothing much to go by, I came to the point of looking at all these various op amps and just checking if I could see diodes on the input. So with an op amp, if you look at the two inputs, and these are obviously dual op amps or normally, so you'll have two inputs on both sides and an output on both sides. And if you connect your red meter lead to the negative supply rail or ground and put your black lead on the input, so effectively you're in reverse polarity to the polarity it normally works in, you can generally see these protection diodes on the inputs and outputs. And if you don't see them, then that basically means that the chip is faulty. The only external thing that could happen that could stop you seeing the protection diode even if it's there is if you have a short. The short could be external, but if it reads open or some other strange reading, then it's the chip. And I can just quickly show you that, and I'll show you what I found on the previous video. Or better still, just go watch it, yeah? But anyway, here you see the multimeter in diode mode, and I'll just demonstrate what I was trying to explain badly. It'll be more obvious. So these are dual op amps. So if I take the red lead onto the negative supply rail, and these are the two inputs, so effectively that is an out, this is in, one is inverted, one is non-inverted, that is an out, this is in. This is a standard pin out for one of these, that's the positive supply rail. So if we look at the inputs, we see this diode, yeah, 0.727, 0.622, and this is the output, 0.622. And if you look on the other one, we should see a similar reading. So yeah, 0.557. It reads like a diode junction. The value may change. Okay. And if we look at another one for comparison again, so this is the negative supply rail, red lead. Diode junction 730, 733, 628 on the output, and then 557, 729, 629 the output. So they're all showing diode junctions. What I'm really looking for is something that reads open circuit or some weird other reading, not a diode junction. If I read a short, like I say, the short could be elsewhere, or those pins could be connected to each other. In normal circuit operation, yeah, it's designed that way maybe. So I did that. I couldn't find any obvious problem here. And bear in mind, I'm doing this without any schematic. I then looked at these chips. So these here, LM13700. And we see we have a data sheet. These are transconductance amplifiers. okay, with linearizing diodes and buffers. It's a kind of an op-amp-ish sort of thing. It has some built-in transistors. It's somewhat different, but it's a sort of. So we can see we have two inputs. We have a diode bias and we have an op-amp bias input, okay? So we have a few input type things there. Out on 12, power on 11. So I was looking actually at these 1, 2, 3, 4 there, and these ones 1, 2, 3, 4. So you can see there's two of these in the package and they're basically the same. I'm connecting my red power lead to pin 6, which is the negative input, and looking for similar diode junctions I saw in those dual op amps, and this is what I found. The chips are the other way up, so we'll just turn this other way up. They are actually the other way up. I was reading the other ones the right way. This is the pin 1, yeah. So on this one, red lead to pin 6, okay? Just zoom in a little bit more. There we go. Red lead to pin 6, and then 2. I'm reading 645, 553, 613, 645 on this side, 652, 553, 613, 651. If I go to the other chip, the one I've marked with an X, pin 6 again, red lead on the negative, 645, and then this reads like it's 1.27, and this also reads like that, and then 661. I come down the other side, 651, 551, 611, 650. So that side reads like that side, but this one doesn't read like this one. And there was a lot of discussion about this technique. It's not perfect, but this will often find you a blown IC where these input protection diodes have blown because the IC itself is faulty, okay? Not always, but if you've got no schematic or anything else, it's a good way to go at it, other than just trying to reverse engineer the whole thing or just give up. So I ordered some of these chips. Some people were saying that external things on the PCB could affect these readings. Other people agree with me and say, look, the diodes are built into the chip. If the junction isn't there, it's something wrong with the chip. It doesn't matter what's connected externally, unless it reads a short, which it doesn't. So we have some chips. And I was about to just read these with my meter to show you guys that these diodes are in the chip. And this is what I found. Okay, LM13700. So pin 6 is the negative supply rail, red lead, reverse polarity basically. Okay, and then we have the inputs. That one, 648, and look, 127, 127, 672, and on this side, 127, nearly going 127, 660. So just playing tiddlywinks there, guys. Richard's wrong in this instance. On these pins, yeah, 2, 3 and 15 and 14, these don't read like diode junctions on this particular type of chip. I made the assumption it does because the other one in the circuit does read like that. Does that mean, in fact, that the other one is faulty? No, I think there's just something else in the circuit that's showing that diode junction. So I didn't know how these would read. I haven't tried them before. Does that mean I was really teaching a bad method? No, I don't think it does. The method itself is good. Just in this case, I didn't actually have prior experience or a chip to have a look to see how another one reads out of circuit. Okay, so I was wrong. Hold my hands up. Those of you who agreed with me in the comments on the previous video, you were wrong as well, but that's my fault also because it was me who put you up to it, yeah? So we still need to fix this amplifier if we can. In the meantime, while I was waiting for these chips, somebody, unusual name like Kalula Luca, a subscriber, emailed me and said, "Hey Rich, I've got the service manual for that thing you're trying to fix." So, thanks mate. We now have another attempt at fixing this. So let's have a look at the schematic. Let's see if we can figure out where the protect LED connects into the circuit, and then see from there if we can figure out why the protect LED is coming on. Is it because there's actually a fault somewhere, or is it that there's a fault in the circuit that generates the protect signal? Okay, let's have a look. Well, I have the PDFs that the guy sent me, but unfortunately these are not the right ones. You can see a speaker here with a bass speaker in. Mine has like the tweeters fit on top of it, and we can see straight away from this diagram this is a completely different PCB to the one I have. The casing is different. This is just different, yeah. There's two versions of this, one with a horn, one without the horn, but it's different. So these are not going to help, even though it says Lucas 600 sub. Okay. And we can clearly see base channel A, B, that this is a linear amplifier class AB. Look, here's your input, your differential pair, basically long-tailed pair as it's called. This is your feedback coming in, this is your speaker connection, and these are the output devices, MJ something or other, big power transistors. Mine doesn't have discrete power transistor output, it has these large ICs. Yeah, you can see this is the balance loop that balances the circuit. That sets the gain with this one compared to the input resistance, okay? So you can sort of see all that, and that is not what I have. So this schematic, although it says 600, is not the same as the Nano 600 that I have. Unfortunately, yeah, it happens. This is also from 2003, which is like 20 years ago, so that is not it. The other service manual schematic that was included was this one, Lucas 2000, which is a bit similar, but again not the same. It has a completely different board. You can see a picture of it there. It looks different again from the one I have. This has a digital interface. The one I have doesn't have a digital input. Okay, so again, that is the wrong service manual schematic for the one that I have. So unfortunately, I don't actually have any more information than I had originally. We can just power this up. We'll just check if the fault is the same. Okay, so turn on. We can see the fault is still here. It just goes directly into protect mode. I'll just set this mode here, A, B. Again, same. Yeah. So let's see if we can get any further with this. This is the connectors of the front panel. I looked at this as much as I could in part one, so go and watch that, guys. But basically what I know is that the mute signal, mute in, mute out, is what's being used to actually hold this amplifier to standby, basically. That's why nothing's happening. Now, that is being controlled by something on this board as far as I can see. Or the signal that controls that is being passed to this board and back out again. Obviously, this is where the LED is, so this is like a dual colour, green or red. At least I think that's what it is. It's going red. And this ribbon is coming down to here. Now, I explored the standby switch and mute circuitry, all these signals in the previous video. We know we have 7.5 volt standby. We know we have plus and minus 15. We know we have the high voltage supplies to the amplifier chips. Switch charge, I'm not really sure what this one actually does. I haven't investigated it. And then we have some signals, so left, right, and sub. So these are your audio signals, yeah, stereo plus sub. And we have one more here that says limited. That's the only one that's actually mentioned on here. And I've got a feeling, but it's only a feeling, that this is what's controlling the protect lights. Probably when we get like a limit, you know, we're overdriving the amplifier, it's clipping, this will just get pulses on it which flash the light. But if it's in protect mode, the light LED is on all the time. And that's, I think, without any other information, is where I need to start. So we'll have a look to see where that signal actually comes from, which is going to be in here somewhere. And let's have a look to see what's on it, voltage, and see if that tells us anything useful. So the signal is on the 4th pin up on this side, 1, 2, 3, 4. And it looks like it goes down that track. Let's just get the meter where you can see it. Okay. Sorry again, guys, my voice is not good. I've just got over a rather nasty cold. But I'm here. Okay, so just have to put up with me a little bit. Yeah, speaking as best I can. So from pin 4 here, that's this track. That goes, yeah, to this capacitor. So we have an electrolytic here. The other end of the electrolytic is the negative end. Does that go to ground? No. So the capacitor doesn't go to ground. Not directly, at least. Go to resistance range. No, so that capacitor isn't going to ground. Where if it does go, that's a bit strange. I thought it would. Well, that's what we have. So if that's not ground, it comes down this. No, I thought it came down this big track, but it looks like it goes up that way actually, onto whatever this is. Seems like that goes up there. Let's have a quick look. So from here, go here. Yeah, yeah. So that's some sort of signal from along here on these capacitors. Okay, so that's what that is. Let's then power this up and let's have a look to see what voltage is on that. Okay. Amplifier on. Protect mode. Okay, red light. What's on this capacitor? So, let's connect to ground. What do we have? We have minus 14.3. That's the positive end. What's on the other end? Minus 15.1. Okay. I'm fairly sure this minus 15.1 is a negative 15 volt supply. And then this is a signal. So although it's reading like minus 14 point something, think about it. This is op amp circuitry. So the op amps will have a plus and minus supply rail. Plus and minus 15, and depending on the inputs to an op amp, the output will either go to, you know, one rail or the other, plus 15 or near, plus 14, minus 14, or 0, or somewhere in between. So there's nothing odd particularly that we have a minus 14 on here and minus 15 on here. Okay, I think I can just double check that. So if I go from here and I find the minus 15, which is marked on the board. Yeah, minus 15 is the second pin in from this end. So that point, does that go to the end of that capacitor? Let's see. Yeah, it does. So that's the minus 15. This is a signal coming out of an op amp that's always going to be more than minus 15 because the op amp can't go below its negative supply rails. That's why negative positive. So something's driving this negative. That's an op amp that's fully turned on. Yeah, that's my guess anyway. So I bet it's your guess as well, at least some of you. So we can see that track also comes through to here. So that must be what's driving it. I think this capacitor is just to stop spikes on here, basically, just to give like a slight delay to the signal going to here. Probably, if this is for clipping, if it's a very short clip, this capacitor doesn't have time to charge up, therefore you don't see the pulsing red light until it's actually clipping enough. Yeah, that's supposition, but what do you think? So, working on the assumption that this shouldn't be minus 15, because that's all we have. Let's see where that goes to. This, of course, is high voltage mains powered, so I do want to be sure that the capacitors have discharged before I start poking around this thing. So the main capacitors, 1.6. This one, 1.1, close, yeah. I'd expect them to be about the same. If one was fully discharged, the other one wasn't, I might suspect something, but I don't. So this pin limiter goes to a via coming through here somewhere. That one, I'm sure it's that one. We can see where the via was. Is that there? Let's put it onto resistance range, that might help, yeah, continuity. Let's have a look, so... yeah, there. Sorry guys, it's off your screen, one moment. You can see where I was, there. Okay, so that's the limiter signal, what's driving it. So that goes to one of these chips, I would imagine. Minus 15, I'm just thinking that's an output from an op amp, so we can go for pin 4, it's the easiest place. Which go to one of these chips. Just have a look down. So let's just no. It could go to like a pull down resistor or something. I was rather hoping it came from the output of one of these op amps. Seems like I'm not so lucky. Well, I can see it goes, there's another via back to the other side of the board, so I'm going to have to go to that. Oh, we could go to one of these. Is it one of these things? No. Well, there's a few more, so we may as well check them. Had something there for a moment. I heard some. No. That's strange, I heard something around here. Strange. No, I can't get it again. It could have been my diode mode on my meter just bleeping a short bleep, which it does. So I can't see where it goes. So we know it comes to here. So I need to find out where that comes back through the board just above. Let's have a look. Oh, interesting. So it goes to this rail here. That one. This end of these diodes. Okay. So, assumedly, the other end of these diodes could be driven by different signals, and anyone could hold this down. This is the cathode. So, yeah, if there's like a low, if there's a high voltage on here, it would go up. Low voltage. Okay, I'm not 100% guys myself. I should do this a different day, but hey. Let's have a look. That reads okay. That reads okay. That reads okay. So the diodes are okay. And something's driving these. You can see there's a via there, there's another via there, there's another via there. So some signals are driving these. And I think this kind of acts a bit like a sort of an OR gate, effectively. I'll just draw it for you, what I'm thinking. Let's have a look to see what voltages we have on the other ends of these three diodes. See if that tells us something useful here. Okay, so protect mode's still on. Ground. What's this one? Minus 13.8. Minus 13.8. Minus 13.8. And then obviously the voltage drop across the diode, 14.3. Okay. So, what do we have? We have a signal here called protect. Prot, yeah, which is going into our panel where that LED is. And that's connected to a capacitor, electrolytic, this way round. And this has minus 15 volts on it. Near as damn it. That's the negative 15 volt rail. We know that because we know where it comes from. We've traced it. And on here, we have minus 14.3 volts. And it goes to 3 diodes. Okay. This way round. And on the other end of each of these, we have minus 13.8 volts. When I started with electronics, negative voltages really confused me. Like my brain couldn't work in that direction or something. But it doesn't now. And it should be obvious to you. There's at least one of these diodes is conducting. And I would say all 3 are conducting. And the reason it should be obvious, the first thing, what's the voltage difference? Well, it's 0.5 of a volt. And that's the forward voltage drop of a conducting diode. Yeah. So regardless of the numbers, the difference should tell you. The other thing as well, with the diode, come on guys, you already know this. With a diode, this end, the anode, has to be positive with respect to this end, the cathode, for the diode to conduct. Is the anode positive with respect to the cathode? All the cathodes are connected together. Is 13.8 negative 13.8 more positive than negative 14.3? Or if you like, is negative 14.3 more negative than negative 13.8? Yes, it's more negative. So this end is more positive. Therefore, the diode is conducting. And without tracing this straight away further than that, I think it's fairly obvious we're going to say that these come from 3 different signals. And the driving device, op amp or whatever, can put a voltage on here, which will change the voltage on here. But look what would happen. For example, if this one had, say, 0 volts on it, the voltage here would go up to, well, about 0.6 volts less than 0, or 0.5, to about 0.5 volts. Because this diode would conduct. What had happened to the two? Well, they wouldn't be conducting anymore, would they? Because this end is more positive. So, no matter what signal you had on here, unless it was more than 0 volts, this would go to minus 0.5. What happens if this went up to the full positive rail, plus 15 volts? Well, this end now would be plus 14.5, because the voltage drop. And these could still be minus 13.8. It doesn't affect them because of the reverse bias. So we can see we have 3 signals, any of which can take this high. Yeah. The only way this can be low is if all 3 are low. Okay. Now that doesn't work the way I would expect a protect signal to work in this kind of configuration. I would expect that any one of these signals can drive this low. Any one. At the moment, if this is kind of quiescent state, they all have to go high to drive this high. Yeah. And I'm not sure that we'd have a fault which meant that all these 3 signals were low. Unless somewhere in this lot we've got some op amp or op amps missing the plus 15 volt supply. If that happened, then the outputs of the op amps would all go down to the negative rail. Well, that's interesting. So let's go and check it. Now, I will say I don't expect to find this fault. The reason being, we already know we have a plus and minus 15 on the previous video here. Okay? And we can just double check that again. And I would honestly expect, before I even power this up, that the plus 15 here will go to the supply of these chips. These op amps. Yeah. Well, actually, goes to that one. Maybe it doesn't. Oh, hold on a sec. Some of the chips are the other way up. Yeah, they're not all in the same direction, like. So, plus 15. Yeah. This one's the other way around. That's the other way around. I think this is the opposite way around again. No. So we can say with confidence actually that it's probably not the case. Which way around is that one? Yeah, it's the other way up. You can see the stripe. Okay. And the minus 15. Well, that'll go to the negative rail. It's there on that way. But hard to see the marking. You see this stripe. There. And then these are the way up. So I don't see that as actually the case. We'll power it up anyway, we'll just prove it, yeah. So from ground, let's just try some of these supply rails. This is what this will do. 14.9 minus 15. So I'm happy enough. I've got supply rails. Okay, so then in that case, and I hope you agree with me about this. This, which we know we have, doesn't seem to operate into any sensible manner that I could think of. But I'm going to take a little bit of a thought about it in case there's something obviously I'm missing. But that kind of like looks back to front to me. Or rather, all of these should all be high. So, well, maybe we need to see where they're coming from. Okay, so I've taken this panel off now. This is the LED, this thing. Sun LED. I think that's a date code 2016-23 EUR 116235-011. I've tried Googling for this number and nothing came up. Is that a 116? I think it is. Yeah. 116235-011. Let's try without the sun LED. No, nothing. So that isn't helping me much. With sun LED, 3 watt round. Is this it? No, that's something completely different. Okay, so there's nothing much to tell me about this LED. What I can see is that it has 8 pins. And it seems, this is ground. Yeah, I know this is ground, so we'll use this. That doesn't go to ground, that reads like a diode junction a bit higher. That end is ground, these two are connected together. That reads like an LED 1.6, okay? A red LED. That doesn't read anything. And that doesn't read anything. Can't imagine they're the other way round. All things are possible. Yeah, this sort of reads like a red LED. I mean, I'd have to just put a bit of voltage on there. In fact, does it do anything? Let's have a look. So just connect my meter to here. Let's see if it lights up. A bit awkward to get at. I'm on it. All this stuff is ground. Yeah, I'm reading the 1.6, but it doesn't appear to light up. And now I've slipped off. Okay, so this is where we're up to so far. I've now got to this point, and the point is that firstly, I'm not 100% sure that protect signal is what's driving this red LED. That circuitry with the 3 diodes either doesn't make sense in this way, or there is something seriously wrong somewhere that's putting all those voltages low and holding them low from, I assume, 3 different sources via 3 different diodes. Yeah, so there's that. The other possibility is that this LED isn't being driven by that signal at all. It's being driven by something else, but the only way to find that out is to find out where the red LED is in this, and find out what drives it, and then find out what inputs are to that and where they come from. So that's the first observation. Second observation, this video is too long. It's the weekend, and I'm going to leave this one till after the weekend, which gives you guys plenty of time to talk about it. Third observation, we have a weather warning. Yeah, granted, we have a weather warning. Let me show you. Weather warning. Sandbar Tom, this is where I live. Yeah. Yellow weather warning for rain. We have a yellow weather warning for rain. What's it going to tell us? It's going to be wet at 1 o'clock. The nearest rain is 178 kilometers away. What? Saturday. That's tomorrow. Ah, the weather alert is for tomorrow. Yeah, rain tomorrow, weather warning, and there you go. So it's going to rain tomorrow. Yeah, in the south and west of Gran Canaria. We're going to have 50 millimeters of rain. That's 2 inches, affecting principally the zones of the interior. So probably not at the coast. Be aware, keep up to date the latest weather forecast. Moderate damage to people may occur in properties, especially. Okay, so that's what a weather warning looks like in Gran Canaria. Today, tomorrow, it's 21 degrees, 20 degrees tomorrow. It's going down to a minimum of 15 at night. But because we might have a couple of inches of rain, that's a lot, we have a weather warning. Do you have those where you live? Let me know. Okay guys, so hope you're having a good weekend. Hope the weather is better where you are than I am. I hope you don't have a weather warning. And I'll see you all soon next week. And we'll carry on with this, okay? Thanks for watching Weird Electronics Repair. Ciao for now, guys.